Hello students and welcome to today's class. I am Dr. Neeti Rathor and I am back again with another video lesson on chemistry. Today let's discuss the most difficult and the confusing topic of chemistry of class 11. Yes, you guessed it right. It is IUPAC Nomenclature of Organic Compounds. Normally students find this topic very difficult and very confusing. Yes, it is little difficult and little confusing. But once you get to know all the rules and regulations to be followed while naming a compound, this will become easy for you all. So let's try to make this topic very easy and understanding. I expect you all to take a copy and a pen and just work along with me, right? In today's lecture, we will discuss only the aliphatic hydrocarbons without functional groups. The aliphatic hydrocarbons means the straight chain ones and the branched ones. I have actually divided the whole nomenclature of organic compounds into different parts so that it is easy for you all to understand. In one go, you cannot understand all the rules and you won't understand, you will get confused. So in today's part, we will only discuss the aliphatic hydrocarbons without functional groups, the very simple ones. So let's begin. First of all, what do you mean by IUPAC? Why am I calling it IUPAC Nomenclature of Organic Compounds? IUPAC is an organization. Its full form is International Union of Pure and Applied Chemistry. Pure and Applied Chemistry. Basically, it is an organization which gives all the rules and regulations regarding chemistry, and this is followed internationally. Clear? So basically, IUPAC has given some set of rules to be followed while naming an organic compound. The first important thing to know is, you all know carbon is tetravalent. Always remember, carbon is tetravalent. Tetra means 4, valent means valency. Carbon has 4 valency, we all know. With this means that carbon can form 4 bonds with different atoms with other atoms. Clear? Now you already know organic compounds are mainly compounds of carbon and hydrogen. Clear? Mostly carbon is bonded with hydrogen atom. So always remember, the first thing to be remembered is, suppose this is a compound. Suppose we have a bromine here. Suppose we have a chlorine here. Suppose, I'm just giving you an example. Just to know this much about this molecule, this compound. So always remember, all the other valency, they are always satisfied with a hydrogen. Are you getting the point? All the free valencies of carbon, like this carbon has 4 valency, 1, 2. 2 are satisfied, 2 are left. So we will fill this valency by hydrogen. Clear? So whenever you find something like this, always remember, suppose this is a compound. So these free valency will always be satisfied by hydrogen. This is the most simplest rule you should know before naming. Clear? Now let's begin with nomenclature of aliphatic hydrocarbons. Aliphatic hydrocarbons without functional groups. Which means we will begin with the very simple ones. Clear? Aliphatic hydrocarbon means straight chain hydrocarbons. They may be straight chain, they may be branched, but they are not cyclic compounds. All the compounds which are acyclics, the compounds that do not contain any cycle, they are known as aliphatic compounds. So they may be straight chain or they may be branched. Clear? So first we will take straight chain aliphatic hydrocarbons, the most simple one. Let's take. Actually, the name of an organic compound contains two parts. A name of the organic compounds basically contains two parts. It is composed of two parts. First is root word and the second is suffix. Root word and suffix. Now what is this root word? This root word is derived by counting the number of carbon atoms. This we have already discussed in class 10th. I think class 10th or 9th. We have already discussed. I'll just make a table for this. Suppose the root word is obtained from here. Suppose the compound contains one carbon. Let me first draw this whole thing. Suppose the compound contains one carbon atom, then the word root will be meth. Meth. M-E-T-H, meth. If there are two carbons, this will become eth. If there are three carbons, the word root will become prop. If there are four carbons, this will be written as but. If there are five carbons, this will become pent. Similarly, if there are six carbon atoms in an organic compound, this will become hex. The root word will become hex. If there are seven carbons, the root word will become hept. If there are 8 carbons, this will become oct. If there are 9 carbons, this will become non. If there are 10 carbons, this will become dec. If there are 11, this will be known as undec. If there are 12 carbons, the root word will become do-dec. Clear? Now, since I said a name is composed of a root word and a suffix. So, suffix, how will we get to know that which suffix we need to add over here? This we'll get to know by the bonds present between the carbon atom. If a single bond is present between carbon-carbon, the suffix will be ane. A-N-E, ane. Always remember. Again, we have discussed this in class 10. If there is double bond present between two carbons, the suffix will be ene. If there is a triple bond between two carbon atoms, the suffix will be ine. Ine, right? We have already discussed about hydrocarbons, alkane, alkene, alkyne. So this is the same thing. Clear? Now based on all these two rules, the root word and the suffix, let's take few examples. Suppose you have a compound like this. This can also be written as CH4. Now, since we have only one carbon atom, we don't have a chain. We have a single carbon atom. So, the root word will be, meth. And only single carbon atom, no single bond, no double bond. So, this will be, the suffix will be ane, methane. Right? Suppose we have another compound, CC, like this. A carbon has 4 valency, right? So, this one valency is satisfied with the other carbon, rest 3. We will satisfy the valency with a hydrogen. And similarly with this carbon, One valency already satisfied. Let's satisfy all other valency by a hydrogen. Now again, this can also be written as CH3, CH3. Always make sure that the carbon has all its valencies satisfied. 3 hydrogen and 1 4. 3 hydrogen and 1 4. Clear? Now let's name this compound. How should I name this compound? Firstly, we will find out the longest chain or the number of carbon atoms. There are 2 carbon atoms, 1 and 2, right? So the root word will be it, and a single bond is there between 2 carbon atoms. So the suffix will be ane. So the name of this compound comes out to be ethane. Is this clear? Is this clear to everyone? The name comes out to be ethane. Similarly, let's take one more example. Suppose we have a compound CH3, CH2, CH3. Now let's find out the longest chain. Of course, the longest chain is very simple. You can number it from here 1, 2, 3, or you can number it from like this 1, 2, 3. You can number it from 1 to left to right or right to left. In this compound, it will be one and the same thing, right? Now, this is the longest chain we have. Number of carbons are 3. So from this table, we know the root word will be prop. It will be prop. And since single bonds are present between 2 carbon atoms, the suffix will be ane. So this compound is propane. This compound is propane. Clear? Let's take one more example. So let's take one more thing. Suppose we have this compound. Hydrogen, 1 hydrogen to make this 4, 1 hydrogen to make this 4, and this will be CH3. Now this is a double bond. Up till now we were discussing examples which contained a single bond. Now this is a double bond. And let me write one more. I'm rubbing this, and I'm hoping you all must have written this in your copies. Let me write this in another way. CH2. Suppose these are 2 compounds. In both the compounds, we have 4 carbon atoms. Right? 1, 2, 3, 4, 1, 2, 3, 4. And both the compounds, they contain a double bond too. Right? And the position of the double bond is different. Only this is the difference between these 2 compounds. Right? Now the point is, my question is, how will you start numbering the longest chain? How will you start numbering? Whether you will number it from left to right or right to left. So here comes another rule of naming, and the rule is the numbering should be done as such. It should be done like so that the double bond gets the lowest number. Always remember, very important rule in IUPAC nomenclature. Whenever we number or we find the longest chain, we identify the longest chain, we always number it so that the double bond or the triple bond, they get preference. they get the lowest number. So let's see, suppose I number this from left to right. This is 1, 2, 3, 4. And suppose I number it from right to left. 1, 2, 3 and 4. In this case, the double bond is coming where? On which carbon atom? 2 or 3? Always use the lowest number. So, in this compound, the double bond is at second carbon atom, right? And in this, the double bond is at first carbon atom. The lowest number is, we are getting in this one. This means the numbering will be done from right to left. Clear? How many carbon do we have? 1, 2, 3, 4. So, the root word will be but. And since this is a double bond, so the suffix will be "ene". This means the name of this organic compound is butene. Right? This is butene. But suppose, let's do one thing. Name this compound also. In this compound, whether you number it from left to right or right to left, 1, 2, 3, 4. In both the cases, the double bond is at the second carbon atom, right? This means we can number it from either of the sides. It will be one and the same thing, right? So, this compound again is but, right? We have 4 carbons, 1, 2, 3, 4. Again, the root word will be but and suffix will be "ene". But in this case, the position of carbon double bond is to be mentioned. This is mandatory. It is mandatory to, when the double bond falls or triple bond falls on the first carbon atom, then you can write it butene. No issues. But if the double bond is somewhere in between, it is mandatory to write, to mention the number of the carbon atom on which the double bond is present. So we will write the name as butene. Clear? This is another rule. Butene. Clear? Whenever the double or triple bond falls in between the carbon chain, anywhere in between, then the position, it is mandatory to mention the position of that double bond. Clear? So this can be written as butene, no problem. But this should be written as butene. We cannot omit this position, this 2. Clear? Let's discuss something very interesting over here. Look at both the compounds. One is butene, one is butene. What is the difference between these two compounds? Let's see the molecular formula of both the compounds. Carbon is 4, hydrogen is 3, 2, 5, 6, 7, 8. C4H8. Now let's write down the molecular formula of this compound. C4, 3, 4, 5, 6, 7, 8. C4H8. Wow! This is a magic. How? The molecular formula of both the compounds is same, right? But their structure, this is, what is this? This is the structural formula, right? So the molecular formula of both these compounds is same, but the structural formula is different. Always remember, such compounds are known as isomers. Isomers. And the phenomena is known as isomerism. Isomerism. Right? So the compounds having same molecular formula but different structural formula are known as isomers. And in this case, what is the difference between the two? Only the position of double bond is different. Right? Position of double bond is different. Therefore, these are known as position isomers. Clear? Are you all getting the point? So these isomers will be known as position isomers. Is it clear to everyone up till now? Let's continue. Now let's take one example of alkyne. suppose this is a compound. Let's take a long chain compound. Suppose this is a compound, organic compound with a triple bond over here. Let's fill all the valencies with hydrogen. Now these two carbons have all the valencies already filled, right? 3 and 1, 4, 3 and 1, 4. So, hydrogen is not required over here, right? Here we will write CH3, hydrogen will be 2. Here again CH2, again CH2, again CH2 and CH3. You can count, okay, you can count yourself that all the valencies are filled with, are satisfied actually. All the valencies are already satisfied. Clear? Now, how will you number this compound? Whether you will number this compound from left to right or right to left? Let's take a look. Let's first number it from left to right. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 carbon atoms. Clear? Now let's number it from right to left once again. 1, 2, 3, 4, 5, 6, 7 and 8. Now if we follow the numbering from left to right, the triple bond comes at carbon 3, at 3 position, right? And if we number it from right to left, the triple bond comes at 5 position. Am I right? 1, 2, 3, 4, 5. So what is the rule? The rule is that the triple bond or the double bond should be on the lowest carbon atom. Lowest number. It should get the lowest number while numbering, right? This means we will follow this numbering from left to right and we will not follow right to left. Clear? Now, there are 8 carbon atoms. So let us write the root word as 8 oct, right? Oct, the triple bond is at carbon 3. So oct 3 ine. It's a triple bond, therefore suffix will be ine. Am I right? The suffix will be ine. Clear? Clear? Now suppose a compound has multiple double or triple bond. Then how will you number it or how will you name it? Let's take one more example. Suppose there is a compound like this. And suppose there is a double bond over here and a double bond over here. Let's take it here. Now let's start numbering the compound from left to right. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So the root word here is non, right? When carbon atoms are 9 in number, the root word is taken as non, right? Now what about the double bond? Since we have multiple double bonds, how will you name it now? Now the rule is when there are multiple double or triple bonds, then prefix di, tri or tetra is used. For example, in this case, we have 2 double bonds, so we will use the prefix di. Clear? But at the same time, it is mandatory to mention the position of both the double bonds. Is that clear? Suppose we have 2 double bonds, we will use the prefix di. And at the same time, it is mandatory to mention the position of the double bonds or of the triple bonds. So let's write the name of this compound. First is numbering. Numbering from this side 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's number this compound from right to left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if we number it from left side, the double bond comes at the position 2 and 5, right? 2, and 5. And if we number it from right to left, the double bond comes at the position 4 and 7. Am I right? Now the point is which one is correct. In such case, we will total this thing. Like suppose 5 plus, we will take the sum of both the positions. 5 plus 2 is 7 and 4 plus 7 is 11. So the condition in which the sum is less, the condition in which the sum is less or it is a smaller number, that is taken as the correct sequence. Am I clear enough to everyone? So in this case, the first left to right numbering will be taken as the correct naming. Clear? So the name of the compound will be written as non 2,5 diene. Non 2,5 diene. Non means there are 9 carbon atoms. 2 and 5 are the position of double bonds. And diene. Diene means, you already know. So the prefix di, tri or tetra is used before ene or ine. Clear? The rule is the prefix di, tri or tetra before ene and ine will be written. So the name of the compound is non-2,5-diene. Is this clear to everyone? Let's take one more example. Let's take this compound and clear, this is a compound. Now let's fill all the valencies. CH3, CH2, CH2 and CH3. Okay, the carbon atom with the triple bond, they already have their valency satisfied, so hydrogen is not required over here. Clear? Now let's start the numbering of this compound. Let's do it from left to right. 1, 2, 3, 4, 5, 6, 7 and 8. Let's number it from right to left. 1, 2, 3, 4, 5, 6, 7 and 8. Now as the rule, what are we going to do? In the first condition, if left to right is taken, then the triple bond falls at carbon 2 and 5. 2 and 5. And if we number it from right to left, the triple bond falls at carbon number 3 and 6. This is carbon 3 and this is carbon 6. Right? So now let's take the total. The total is 7 and here the total is 9. So what do we need to take? We need to take the lowest number. Clear? So this means we are going to follow this numbering system from left to right. Am I clear enough? So as per this rule, the name of this compound becomes, there are 8 carbon atoms. So oct is the root word. 2, 5. Oct 2, 5 diene. Oct 2, 5 diene. Clear? We need to use the prefix di before ine or ene. Clear? Is that clear? After this, let's take an example where double and triple, both multiple bonds are present. In that condition, how will we name the organic compound? First of all, let me write this example. CH, triple bond C, single bond C, double bond CH, single bond CH, double bond CH2, That's it. 3, 6 carbon atoms. 3 and 3, 6. Okay, so this is your compound. Now, how will you number this compound? Let's try both ways. Let's number the compound from left to right. 1, 2, 3, 4, 5 and 6. In this case, the multiple bonds are falling on carbon 1, carbon 3 and carbon 5. Am I right? So let's take the sum rule. 1, 3 and 5. The total becomes 9. Clear? Now let's number this chain the other way round. 1, 2, 3, 4, 5, 6. Now the multiple bonds are falling on carbon 1, 3 and 5. 1, 3, 5. Again the total is same. So we can take any of the ways. Both will be correct. Clear? So I am taking this one. I am taking this one. So according to this, the name becomes, what does the name become? Always remember, the triple bond becomes the suffix. That is the rule. The rule is that triple bond becomes the suffix -ine. Clear? So we will write the name of this compound as hex word root 1, 3, diene, 5, ine. Clear? The suffix is the triple bond. Or you can also write it like this: 1, 3, hexadiene, 1, 3, hexadiene, 5, ine. 5, ine. Clear? 5, ine. This means the triple bond is at 5th carbon atom, right? And on 1 and 3rd carbon atom, double bond is present. Clear? So out of the two, the triple bond is taken as a suffix. Clear? And double bonds are taken as. Now we have already discussed, we are done with aliphatic hydrocarbons. Which ones? Straight chain hydrocarbons, straight chain organic compound. Now let's take branched chain organic compounds. Branched chain. Now what does this mean? Branched chain organic compounds without functional group लेंगे हम. Okay, we'll take without functional group. Now, suppose there's a tree. So, as is the case with a tree has many branches, right? Similarly, if there are some group of atoms which actually pops out from the main carbon chain, then they are known as branches. How? Suppose this is a carbon organic compound and this is written like this. Suppose. Let's fill the CH2, CH3. Clear? CH3, CH2. Now in this compound, let's take the main chain. Let's identify the longest carbon chain in this compound. The longest carbon chain is this one, right? And this group of atom, this CH3 group is actually out of this. It is not falling in between the main carbon chain. So this will be known as a branch. Okay? And this compound will be known as a branched chain organic compound. Am I clear? A straight chain compound with a small group of atoms here and there, not falling within the main carbon chain, they are known as substituents. These molecules, these group of atoms are known as substituents. and the compound is known as a branched chain. This compound may have a branch over here also, CH3. Again, this will be a substituent. Clear? Now, at this point of time, we need to discuss one more thing. The branches mostly are alkyl groups. These branches are mostly the alkyl groups. Now, what is an alkyl group? Alkyl word is derived from alkane. Alkyl word is derived from alkane. If you remove one hydrogen atom from an alkane, the remaining molecule is known as the alkyl group. How? Suppose CH4 is an alkane, methane. Now you kick out one hydrogen from here. You will get CH3. This is methyl group. So easy. Alkane, alkyl. Methane, methyl. That is so easy. Are you getting the point? Suppose this is C2H6. C2H6 is ethane. You kick off one hydrogen from this molecule and this molecule becomes C2H5. So this is ethane. This will become ethyl. Right? So methane gives methyl, ethane gives ethyl, propane gives propyl, butane gives butyl. So these are alkyl groups. What are these? These are alkyl groups and these are mostly found as branches in a branched chain organic compound. I think I am quite clear in this now, right? So I hope you people are getting the point. Now let's take an example and try to understand this thing. Suppose there is a compound like this. Suppose this is a branched chain organic compound. First of all, we will look for the longest carbon chain, and this longest carbon chain actually contains 7 carbon atoms, right? How many carbon atoms? 7 carbon atoms. So let's start numbering from left to right. 1, 2, 3, 4, 5, 6, 7. From right to left, 1, 2, 3, 4, 5, 6, 7. Now in a branched organic compound, there are two possibilities. You can count it like this also, but you can count it like this also. Suppose we count it as 1, 2, 3, 4, 5 and 6 carbon. In this case, this remaining part will become the substituent. Are you getting the point? This will become the substituent. But the point is, the problem is that we need to find out the longest carbon chain. So if we count it like this, we are getting 6 carbon atoms. And if we count it from right to left, we are getting 7 carbon atoms. So we need to take this one, the longest carbon chain containing 7 carbon atoms. Now what is the rule over here? Now the rule is that the substituent group should fall on a carbon atom with the lowest number while numbering. Are you getting? So if we consider from right to left, the number we are getting is 5, and from left to right, the number we are getting is 3, right? So this sequence is the correct sequence from left to right. What is the root word? 7 carbon atoms. The root word is hept. There is single bonds only, so this is heptane. And always remember that the substituent group is always written as a prefix This is again a rule that the substituent atom is always written as a prefix. So what are we going to write here? We will write, first we will mention the position 3, then we will write a comma and the name of the substituent group like this, 3-methylheptane. So the name of this compound is 3-methylheptane. It is a heptane with a methyl group as a substituent on the third number of carbon atom on the heptane. Suppose we have a methyl group over here and suppose we have a substituent over here. Numbering from left to right, 1, 2, 3, 4, 5, 6, 7. You already know the valencies are to be satisfied with hydrogen, CH3, CH, CH2, CH2, CH, CH2 and CH3, right? Let's number it from right to left. 1, 2, 3, 4, 5, 6, 7. Now, what is the rule followed in this condition? The rule followed will be same as that we followed in multiple double and triple bonds. How? What is the rule? Suppose from left to right, the numbers are 2 methyl, position are 2 and 5, right? And if we consider from right to left, the position of the methyl groups is 3 and 6. 3 and 6. The total of this will be 7 and the total of this is 9. So what are we gonna take the final name as this 7. The lowest number is taken. This means we will follow the left to right sequence. Clear? So now let's write down the name of this compound. This compound is 7 carbon atoms with all single bonds. So this will be heptane and methyl group at position 2 and 5. So we will write 2, 5. You will use the prefix di. Yes. Similar to the case with the multiple double and triple bonds. Whenever we have multiple substituents, we will mention their positions, and if the substituent groups are same, then we will use the prefix di, tri or tetra. Right? Are you getting the point? We will use the prefix di, tri or tetra. So here the prefix will be 2,5-dimethylheptane. 2,5-dimethylheptane is the final name of this organic compound. Clear? I hope this is clear to everyone. Let's take one more example. CH3, CH, CH2, CH, CH3. Okay, now how will you name this compound? The first step is to find out the longest carbon chain, right? So the longest carbon chain is 1, 2, 3, 4, 5, this one. You can also take it like this, 1, 2, 3, 4, 5. In that case, this will become a substituent and this will become a substituent. Are you getting the point? You can select the chain like this, or like this. All are correct. The only thing is you cannot go like this and then come back. That is wrong. You need to go in the same direction. Clear? We can also take 1, 2, 3, 4, 5. In this case, this will become a substituent and this will become a substituent. Am I clear enough? So I am taking the straight carbon chain. Let's take the straight carbon chain 1, 2, 3, 4 and 5. If we are following this sequence, then the methyl group is present on the second and the fourth carbon atom. And let's write it down, 2, 4. Now let's count it from right to left, 1, 2, 3, 4, 5. Again the methyl group is falling on 2 and 4 carbon atom. In this case, we always take the sum of this. This is known as the sum rule. This is known as the sum rule. So this is 6 and this is 6. It is coming as equal. Okay, the rule is to take the sum of these positions and the lowest one is chosen. The final name is written as the lowest number, right? So in this case, the total is same. So we can take any of this sequence. Clear? So I am taking this one and not this one. So now let's write down the name. The word root is 5. All single bonds in. Pentane 2, 4. 2, 4 dash dimethyl. Right? We just now discussed substituent is when present in more than one number, then di, tri, tetra. Di and tri prefix is used. Clear? So the final name of this compound will be 2,4-dimethyl pentane. Let's take an example where a single substituent, same substituent is present for more than 2-3 times. Suppose a single same substituent or same alkyl group is present for more than one time, then what is the condition in that case? Let's take an example. Now this is an organic compound in which you can see methyl group is there. 3 methyl groups are present in this compound as a substituent group. Now in this example, there are 3 methyl groups on different positions. Clear? Now in this also we will follow the sum rule. What is sum rule? First let's count the carbon atoms from left to right. 1, 2, 3, 4, 5. In this case, methyl group is falling on position 4 and 2 are falling on position 2. So we will write 2 times 2, 4. Sum is 8. Clear? Now let's count it from right to left. 1, 2, 3, 4 and 5. Now in this case, 2 methyl groups are falling on 4 position. So 4, 4. This one is on 2 position. 4, 4 plus 2. This is coming out to be as 10. This is the sum rule that we are following. So what is the rule? The rule says that the lowest sum is taken as the right sequence. Clear? So this way, the name of this compound will become, we will follow this left to right sequence. So as per this sequence, the name of this compound will become written as 2,4 trimethyl. The root word is pent. All single bonds are there. Therefore, pentane. 2,4 trimethyl pentane. Now remember one thing. If there are 2 methyl groups on a same carbon atom, then we will write the number twice. 2 methyl. You cannot write 2 because there are 2 methyl groups on the same position. So you need to mention the position twice. 2,4 trimethyl pentane is the right name of this compound. Is this clear to you? We actually followed the sum rule. We have taken the sum rule. Clear? Take an example with multiple substituent groups. Suppose we have a compound and we have a substituent over here, C2H5, ethyl and methyl. So we have two different substituents. So what will be the case? Let's discuss. First of all, let's fill the valencies. Valency of carbon, CH2, CH2, CH, CH2, CH2 and CH3. Let's start numbering from left to right. 1, 2, 3, 4, 5, 6, 7, 8. This is the longest chain that we have taken. This is the longest chain we have taken. 1, 2, 3, 4, 5, 6, 7. If we take it like counted like this, 1, 2, 3, 4, 5, 6, 7. Actually, it has 2 carbon atoms. This will become 7. But we need to choose the longest carbon chain, so it will be, we will choose this main chain. Now number it from right to left. 1, 2, 3, 4. Let's do one thing. Let's find out the position of both the substituents. Methyl group is getting a position of number 2, and here we are getting the position 2 and 5. If we count it the other way round from right to left, let's number it 1, 2, 3, 4, 5, 6, 7, 8. In this case, the number will be 5 and 7. 5 and 7 position of the substituents. As we have done earlier, we will total this. This will become 7 and this will become 12. So we will consider the lowest number. This means we will follow the sequence from left to right. Comes another rule of nomenclature, and the rule is when two different methyl groups, when two different alkyl groups are present in the chain, then all other rules will remain same. Only while writing, we will write the name in alphabetical order, which means name of ethyl will be written first, then will come methyl, then propyl, etc. Are you getting the point? The rule is when two different alkyl groups are present in the longest chain while naming, the rule is that it will be named according to the normal rules, with only difference is that the name of the substituents are written in the alphabetical order. How? Let's see. Now the final name of the compound comes out to be final name of the compound comes out to be 4-ethyl we are following this order now. 5-ethyl. The final name, so the final name of the compound will be 5-ethyl because E comes before M. 5-ethyl, 2-methyl. Root word is oct. All single bonds are there, therefore ane. So the final name of this compound will be 5-ethyl 2-methyl octane and not 2-methyl 5-ethyl octane. Why? Because while writing the names, alphabetical order will be followed. So as per that alphabetical order, E comes before M. So we will write ethyl first and then methyl. Is that clear? Let's take one more example. So this is the next example I am taking. Now let's name this compound. How are you going to name this compound? We just now discussed alphabetically. If let's see, alphabetically this is ethyl group we know, and these are methyl groups, right? So alphabetically E comes before M. So we will number this chain in such a way that this carbon atom gets the lowest number, right? So let's name it from this side, number it from this side 1, 2, 3, 4, 5, 6 and 7. Clear? Now, what are we going to do in this case? Let's write the name of the compound. Now, name is 3-ethyl 6,6-dimethyl heptene, right? 7 carbon, all single bonds. So this will come as heptane. Now some of you will ask or say, ma'am, D comes before E, so this should come before this, right? So you can write the number as 6,6-dimethyl and so on. But I would say this will be wrong. Why? Because always remember that the alphabet, this prefix di or tri, is not considered in this rule. Yes, when we write the name of substituents in alphabetical order, then E of ethyl and M of methyl is considered and prefix di tri is not considered. Am I clear enough? So if you will write the name of compound like this, it will be wrong. So you need to write it 3-ethyl 6,6-dimethyl heptane. This is the correct name of this organic compound. So now you got the point. If two different groups are present, always the carbon atom with the substituent group which alphabetically comes first, that carbon should get the lowest number. And that is why I have again taken an example and explained to you everything so that you get the picture is very clear in your mind. Clear? So to make the picture very clear in your mind, I have again taken one more example to explain this whole thing. Clear? So now I think you are understanding, you are learning the rules step by step, right? Because we are discussing all the rules step by step with examples. So now this will be very, very clear to you. And this will be more clear to you if you are practicing it right now along with me. Clear? So I am expecting that everybody is practicing along with me with their pen and copy. Clear? So let's take one example. CH2, H, CH3, CH2, CH3. Suppose we have a substituent and a double bond, both present in the organic compound. Then how will you name this compound? The first rule is to identify the longest carbon chain, right? Longest carbon chain should be this 1, 2, 3, 4, 5, right? But this is not the correct sequence. Why? Because it is a rule in a branch chain compound, if there is a multiple bond present, the multiple bond should be present in the longest carbon chain. Getting the point? The multiple bond, whether it is a double bond or a triple bond, it should always be present in the longest carbon chain, right? Which means we cannot take this sequence 1, 2, 3, 4, 5. No. We will actually take this sequence. We will take this 1, 2, 3 and 4. So this will be our longest carbon chain containing the double bond. If we will take this carbon chain, the double bond is not coming in this main chain, right? So we need to identify the longest carbon chain containing the multiple bond. Clear? So this will be our main longest carbon chain. And how we will number it? We will do the numbering in such a way that the carbon with the double bond gets the lowest number. That's the rule we are following up till now, right? So the rule is the carbon with the double bond should get the lowest number. Therefore, numbering will be done as 1, 2, 3 and 4. And in such case, this will become as a substituent and this will also become a substituent now. Clear? So now let's name this. Let's name this. The compound becomes 2. Now there is one more problem in this compound. We have two different substituents. Two different substituents we have. So what are we going to do? At 2 position we have ethyl group. At position 3 we have methyl group. So how will you name this compound now? Always the one which is the one, in such case we will write the name of the substituent groups in alphabetical order. Right? In alphabetical order. So we will write ethyl group first. The name of this compound will become 2-ethyl. 3 pe we have, at 3 position we have a methyl group, comma 3-methyl, 2-ethyl, comma 3-methyl. This is 1, 2, 3, 4 carbon. But, right? But 1-ene. So whether you write it a but1-ene or butene, it's one and the same thing. Now let's move on. Now let's make this more complicated. Now suppose the substituent of an organic compound, suppose the substituent is further branched. Then in that case, how are we going to name that compound? Let's take an example of this case. For example, let me take an example of 10 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On this position we have CH and in bracket we have CH3 whole twice. Then here we have CH2, CH3. On this position we have CH, CH2, CH3 and CH3. Yes. Let's fill the valencies with hydrogen. Suppose this is the organic compound which we have to name now. Now the substituent you can see, here we have the substituent 1, 2, 3, 4 with 4 carbon atoms, which means this is a butyl group, and here we have 2 and 1, 3 carbon atoms. So this is a propyl group, right? Now this propyl group is, let's open this up, it is actually like this. And from here it is attached to the main carbon chain. So this is basically which group? This is isopropyl. This is isopropyl group. So we actually need to name these substituents individually. We need to name these. We will name these substituents individually along with the name of the whole compound. Clear? So this substituent is isopropyl, right? Now let's take this substituent. This substituent is attached from this position with 4 carbon atoms. This is basically sec-butyl. This is not normal butyl. This is sec-butyl, secondary butyl, attached to the second carbon atom with the main chain. Let me write it here. CH3, CH, CH3, and from here it is attached to the main carbon atom from with the secondary carbon atom. Clear? So this is secondary butyl, sec-butyl. Clear? We can also do one more thing. Let's number the chain now. Now we already know, up till now we have become an expert that we will start numbering from left to right. Why? Because the substituent group is falling on carbon number 3, right? So we will number it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's write the name. We will write the name like 3, 3, 2, 3, 4. Okay, so how will we name the compound? Tell me. In this case, we will consider this again in alphabetical order. B of butyl and P of propyl. B comes before P. So we will write 4 sec-butyl, comma 3 isopropyl, 3 isopropyl, 10 carbon atoms, dec, all single bonds, so decane. So the name of this compound becomes 4-sec-butyl isopropyl decane. Now this sec-butyl and isopropyl are common names of these substituents. They are not the IUPAC names. So writing common names is also allowed, but you can also write this in IUPAC format. How? So we can write the name as 1-methyl, 2 carbons, ethyl, 1-methyl ethyl. The IUPAC name of isopropyl will become 1-methyl propyl. Why ethyl and not ethane? Because it is a alkyl group. It is a substituent alkyl group. Right? It is a branched substituent, branched alkyl group. So we cannot write 1-methyl ethane. We will write 1-methyl ethyl. Clear? So the name of this sec-butyl will now become 1-methyl, 1, 2, 3, propyl. 1-methyl propyl. Clear? Why propyl? Because this is attached to a main chain. This is a substituent group. So we cannot write 1-methyl propane. This is not propane. This is 1-methyl propyl because it is an alkyl group. Don't forget. Okay, this is the most important thing to be remembered over here. Since it is an alkyl group, it is a substituent. Therefore, propyl, ethyl will come. Ane will not come. So now the final name of the compound will become. How will you write this? You will write 4 in bracket 1-methyl propyl, bracket closed, 3 in bracket 1-methyl ethyl decane, that you already know, decane. So you will mention the position of the branch substituent, and then in bracket you will write the IUPAC name 1-methyl propyl. Then again you will write the position of the substituent. Again in bracket you will write the name, IUPAC name of the branched substituent, 1-methyl ethyl and decane. So final name of the compound becomes 4,1-methyl propyl, 3,1-methyl ethyl decane. Clear? You can also write sec-butyl and isopropyl. They are the common names, but they are permitted in IUPAC nomenclature. You can write that name also. It is one and the same thing. Clear? But I think it's good if you write the IUPAC name. It's better. Again we have, let's take 8 carbon atoms. Let's take 9. CH3. Now this is the compound. Here you have CH2, C, CH3, CH3, CH3. Just by looking at it, don't get scared, oh my god, this is so difficult. No, it is not at all difficult. This is the example of substituted, this is an example of branched substituted groups, right? This substituent, this whole molecule is a substituent. This whole is a substituent. It is a branched substituent. So we will name this separately, right? And then we will follow the order. Clear? Now let's name this substituent. Let's name this whole substituent. How will you name this? We can name it like this, 1, 2, 3 also. You can name it like 1, 2, 3 also. Any way you can go. Let's number it like this. 1, 2, 3. So we can write the name of this branch substituent as 2,2-dimethyl and propyl. Propyl or propane? It has to be propyl because it is an alkyl group, remember, attached to a main carbon chain. We cannot write 2,2-dimethyl propane. Instead, we will write 2,2-dimethyl propyl. Clear? And the final name of this compound will become what? The final name of this compound will become 4. You can also write neopentyl. Why? Because this is neopentane basically. The common name is neopentane. And when it is an alkyl group, so it will be neopentyl. This will become as neopentyl. Clear? So the name can be written as 4-neopentyl. It is a nonane. 9 carbon atoms, all single bonds. So nonane. So IUPAC permits to write the common name also. But as I said, it is better to write the IUPAC name. So the IUPAC name will become 4. The position of this substituent in bracket 2,2-dimethyl propyl nonane. So this is the final name of the compound. 2,2-dimethyl propyl nonane. Is that clear? I hope this is clear to each and everyone. Let's take one more example. Now let's take an example where substituent group and double or triple bonds both are present. Clear? This is an example. This is a compound in which a multiple bond and substituent groups both are present. Now first step is to choose the longest carbon chain. Clear? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You can take it like this also. Like this also you can number. 1, 2, 3, 4, 5, 6. In this case, these two will become the substituents. Substituent groups. Clear? I am taking the normal longest chain. If the longest chain is straight, why not take that only? So I am taking this one. Clear? Now, the rule is whenever a double or triple bond and substituent groups both are present, the priority is given to the double bond or the triple bond. What does this mean? This means that the carbon with the double bond or triple bond should get the lowest number while numbering. Clear? So, in this case, when substituent groups and double bond both are present in the carbon chain, then the priority will be given to the double bond or the triple bond, which means the carbon with the double or triple bond should get the lowest number while numbering. So let's number it this way. 1, 2, 3, 4, 5 and 6. Clear? Now let's write the number of this compound. How will you write the name? First of all, 6 carbon atoms, hex, 5, 5, di, 5, 5 dash, dimethyl, hex, 1 ene. Or you can write it like this, hexene. Why am I saying this? I am saying this because you already know if if the position of the double bond is not mentioned, it is automatically understood that the multiple bond is present on the first carbon atom. Clear? So whenever the multiple bond is present on carbon number 1, you can write the number, mention the number, or you may not write it. Both are correct. Clear? But suppose if this double bond is on in some other carbon atom, carbon number 2 or 3, then you need to specify its position. Clear? So the name of this compound becomes 5,5-dimethyl hexene or hex 1-ene. Both are correct. Clear? Let's take some questions for practice. Okay? On what we have discussed up till now in aliphatic hydrocarbons without functional group, let's take some questions for examples. Suppose we have a compound like this and this. Now this compound is basically a line structure. So here this is a carbon, 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 and this is a carbon. So total we have 1, 2, 3, 4, 5, 6 carbon atoms. So hex, if we number this compound from this way 1, 2, 3 or from this way 1, 2, 3, in both the cases the double bond is at 3 position. So we can number it from any of the ways, either of the ways. Clear? So let's number it like this: 1, 2, 3, 4, 5 and 6. So now we will write the name of this compound as how much? 2-bromo hex dash 3-ene. 2-bromo hex 3-ene. Now what is this 3? This is the position of the double bond. 3 means the double bond is present on third carbon atom. Clear? Let's take one more example. Suppose we have one more compound. Suppose you have one more compound like this. Now again, this is a carbon, this is a carbon, this is a carbon and this is a carbon. So let's take the longest chain. Suppose if we take this longest chain, this will become substituent methyl group. Or if we take, suppose we take 1, 2, 3, 4. No, we can't take it like that. Yeah, if we take it like that, 1, 2, 3, 4, this will become substituent. If we take it 1, 2, 3 and 4, then this will become a substituent. Let's number it like this: 1, 2, 3 and 4. Now this is a methyl group, always remember. This is a methyl group. So now the name of this compound will become as 2-methyl 4 carbon, there are 4 carbon, all single bond. So 2-methyl butane. The name of the compound is 2-methyl butane. Clear? Now see, we have practiced enough questions for aliphatic organic compounds without function. So that's all in the first part. I am not explaining the whole nomenclature in one go because it becomes very difficult to understand the whole thing in one go. So in the first part, I have explained you only the aliphatic organic compounds without functional group, straight chain and branched both. So practice the examples of these, and in the next class we will discuss organic compounds, aliphatic organic compounds with functional groups. Until then, you practice these. So see you in the next class. Until then, goodbye. See you.